All right, good evening, ladies and gentlemen. Here we are with our homework, our 5.9 video. Very first thing that we have to do is go to our table of contents. We're going to shame Aiden Seamster, who's here with me right now. He doesn't have his journal. David, are you writing this in your table of contents?
Yeah.
5.9, factoring with A equals 1. And that's going to be the title of our brand new fresh sheet of paper. So you're going to turn in your journals to find your fresh sheet. And on the right side of our packet, or right side of our notebook rather, we'll do the big title 5.9, factoring with A equals 1. Draw your line going down and your line across to set up your Cornell notes. And the very first question that we're going to write on the left side is, what is a factor? And a factor is what can you multiply together to get a term or expression. For example, 5 times 10 equals 50. So the two factors of 50 are 5 and 10. 5 and 10 multiply together to equal 50. In that same way, x plus 5 times x plus 10 equals, using the box method or using the FOIL method, I'll save us the time, it equals x squared plus 15x plus 50. The two factors of this expression right here are x plus 5 and x plus 10, because these two things multiply together to equal this longer expression. Your second question you're going to write on the other side is, what is a term in a quadratic equation called? So if we have ax squared plus bx plus c, that's our standard form of our quadratic function. Our ax squared term is called our quadratic term. And that's because it has the x squared. Feel free to color code your notes. I like making mine look fancy, so I'm color coding mine. My bx term is what's called my linear term, because it just has the singular x without the x squared. And then your c term, it doesn't have a variable.
Attention all scholars, will Abel Morales please report to the front office?
It's called your
Abel
constant term.
Morales, please report to the front office.
Because it has no variable. Steps to solve by factoring. It's going to be our final thing that we read on the left. Number one, you're going to label your A term, your B term, and your C terms. Number 2, you're going to set up your diamond. And this is going to be what we do tomorrow. You're going to set up your diamond. This will make way more sense tomorrow when we actually do these. But there are going to be 4 different types of diamonds. If you have a positive term and a positive term on the top, that means that your left and right terms are also going to be positive. If you have a positive term on the top and a negative term on the bottom, you're going to have 2 negative terms on either side. Again, this will make a lot more sense when we actually do one. You have a negative term on the top and a positive term on the bottom. One of your terms will be negative and one of your terms will be positive on the left and the right. If both of your terms are negative, one on the top and one on the bottom, one of your terms will be negative and one of your terms will be positive on the left and the right. Put a box around these 2 diamonds. These are the same. So one term is negative and one term is positive. Step 3 is to find your factors to complete the diamond. Number 4, write the factors. In step 5, set each factor equal to 0 and solve for x. All right, so I'm going to give you guys an opportunity to finish that. Let me move this. I'll move back out, gentlemen. Hang tight for those of you who are watching the video. Because I'm going to have you guys do a couple examples here. Okay. Example number 1. We're going to set up our diamond. We'll start off with an easy one, 90 and 19. Okay, so gentlemen, this is where I'm going to need your participation. I've got Dave and I've got Aiden with me. Everybody can, Armani's grading. Okay, so gentlemen, these diamonds are going to be what we're doing tomorrow. This is what we're going to spend just tomorrow doing. All of this stuff that we just wrote down as our steps, we're going to do over the next couple of lessons. So what I'm asking you guys to do is which 2 numbers multiply to 90 but add to 19? What 2 numbers can we multiply together to equal 90 but add them to be 19? 9 and 10. Let's do another one. Let's do 10 and 7. Which 2 numbers multiply together to equal 10 but add to be 7? Think about it. What 2 numbers multiply to be 10 but add to be 7? 5 and 2. It doesn't matter which one you put on the left and which one you put on the right. Let's do a medium one. I think you guys can get this one though. What about negative 120 and positive 2? Now look up here where I have your diamond problems, if I have the negative number on the top and a positive number on the bottom, that means one of my numbers has to be a negative number and one of them has to be a positive number. You guys with me? So which two numbers, one of them being negative, have to multiply to be 120, but add to be 2? $12, and what else? What's 120 divided by 12? Negative 10. Because negative 10 times positive 12 is what, Aiden? Negative 120. But 12 minus 10 is what? 2. Let's do one more. Let me see if I can find one that's tricky. Thank you guys for holding. Negative 28 and positive 3. So again, this is the same thing. One of them has to be negative and one of them has to be positive. What two numbers are going to multiply to be negative 28 but add to be 3? Or in this case, subtract, because one of them has to be negative.
Negative 7 or positive 7 and negative 4. That work? Yeah.
Aiden wins! And that's going to be what we do tomorrow, guys.
Whatever.